आइएगा जरा 2-3 न्यूमेरिकल सॉल्व करते हैं फ्रॉम IRODOV. फर्स्ट वन इज that is this is the circuit. We have to find the equivalent capacitance. In this we are given 3 capacitors, each of capacity C1, C2 and C3. देखिए A यहाँ कनेक्ट किया हुआ है कनेक्शन, और यहाँ से इस पॉइंट से B पर कनेक्ट किया हुआ है. Now we assign any arbitrary potential. A को मैंने 1 दिया है, तो this is 1, this becomes 1, this becomes 1, this is potential 1. Now you see that the other plates, this, if I assign the potential 2, this is at 2, this is at 2, and again this goes to this plate. So you say that 1 2 2 1 1 2. It means that the 3 capacitors are having equal potential differences across them, that is 1 2 1 2 and 1 2. When potential difference is same, then you can say the capacitors are connected in parallel. So CAB, it is equal to effective capacitance C1 plus C2 plus C3. It is equal to total sum. Now if I replace each C1, C2, C3 equal to C, then the result becomes C effective. That is the total effective capacitance between A and B becomes 3C. So इस तरह के क्वेश्चन में आप क्या करेंगे? You will assign any arbitrary potential टू पॉइंट A, और जो भी सिमिलर पोटेंशियल पर होंगे उनको इक्वेट करेंगे. यहाँ पर हमारे पास 3 कैपेसिटर हैं, तीनों के अक्रॉस सेम पोटेंशियल डिफरेंस है, देयरफॉर दे आर कनेक्टेड इन पैरेलल. नाउ लेट अस कम टू दिस पॉइंट, दिस क्वेश्चन. ये बिल्कुल एक एग्जैक्ट हमारे पास व्हीटस्टोन ब्रिज है विच इज बैलेंस्ड. ये पॉइंट मैंने A यहाँ लिया है, B यहाँ लिया है, ये C ले लिया और ये D ले लिया. यू कैन सी P by Q is equal to R by S, C by C is equal to C by C. It means this Wheatstone bridge is balanced. So the point C, I can say this is point C, this point is D. These are equipotential. No charge flows through this part, and therefore it can be deleted. So our circuit becomes C. These two capacitors C and C, these are connected in series, these are connected in series. अपर पार्ट में देखिएगा जो हमारा इफेक्टिव रेजिस्टेंस है सीरीज में C/2 आता है, लोअर पार्ट में C/2 आता है. अब ये C/2 और C/2 को ऐड करेंगे, ये पैरेलल के अंदर है, डायरेक्टली ऐड होगा, एंड वी विल गेट द आंसर. So this is all about this second numerical. Now let us come to the find the charge on each capacitor in this circuit shown below. देखिएगा ये हमारे पास सोर्स EMF का E1 है, यहाँ पर E2 है. दोनों के जो नेगेटिव टर्मिनल्स है both are in the same direction. So in this case the effective potential will be the, you can say, difference of the two potential differences. ये हम assume करेंगे कि एक EMF ज्यादा है और दूसरा EMF कम है. So let us assume that this EMF is E1 is greater than E2. So naturally the effective EMF in this circuit will be equal to E1 minus E2, and the capacitors C1 and C2 are connected in series. Therefore same charge appear across the plate of each capacitor. So this effective EMF must be equal to the voltage, sum of the voltage drop across each capacitor, that is Q by C1 plus Q by C2. E1 minus C2 is equal to Q by C1 plus Q by C2. Q कॉमन लेंगे, ये कैपेसिटर सीरीज में है, 1 upon C1 plus 1 upon C2. This is C1 C2, and similarly you can write down C1 plus C2. अब Q की वैल्यू यहाँ से इक्वेट कैलकुलेट करेंगे, that is Q is equal to E1 minus E2 into C1 C2 upon C1 plus C2. So this is the answer charge on each capacitor. Now if we assume that E1 is equal to E2, then there will be no charge on any of the capacitors. Thank you very much for watching the video.